I'm Michael Widenius, creator of MySQL and MariaDB, and I will try to talk a little bit about my view of big data and where we stand today and what to expect. And I will have about 5 minutes at the end for questions. So if you see something you want to know more about, remember and let's talk about it. So everybody talk about big data and how much data we are going to store. So now we are at 2016. There are some 12 zettabytes in the world, which is 12 million petabytes. So these are the things that you need to learn: zettabyte, exabyte, and petabytes. And we expect to store more and more data. Here's some of the big data in the world that I pulled out from various resources. And there you have Facebook and Twitter is probably the companies who have stored the most themselves, and most of those are spread. I'm actually happy that spam is down, which I didn't know until I was researching this one. But what I'm most happy about is that big data nowadays is driven a lot by open source, which was not the case when I started with MySQL in the old times. You have MySQL and MariaDB, you have, and we have added lots of things to be able to handle much bigger data sets as before, and Apache's Cassandra, MongoDB, Couch, HBase, and Hawk and others. But the nice thing nowadays is that you don't really need a lot of money to start to work with bigger data sets. I know that's lots of companies that I haven't mentioned, but these are the common ones that I, in my world, see a lot of. Here's some database usage about according to the Tesora survey, where they had sampled 500 DB users, most from big companies. You see a lot of SQL Server, which I haven't seen in the other surveys I've seen. MySQL and MariaDB is still going strong, and Oracle. But the interesting thing is that the NoSQL word are so much spoken about actually are using or used by only 10% of the companies, and actually only for a fraction of the data. Still have the old legacy databases with some extent MySQL and MariaDB is part of, handle those. And still about 80% of all websites are using MySQL or MariaDB as a backend. There's lots of NoSQL companies here at the conference, and the reason I've seen why NoSQL is used is that they promise faster replication and much easier usage. One of the strong points of NoSQL and why you should use NoSQL is it's easier to use. And as somebody who's worked with relational databases, there's some advantage and disadvantage I can see with that. It's kind of strange that almost all NoSQL vendors are adding SQL. So the question, will they also change the name to be SQL in the future? But my view of data and looking at big data and the challenge with big data is that you need to also be able to manipulate that, not only today, but in the future. So I see that NoSQL's biggest strength and biggest weakness is unstructured data, and we'll talk about that later. So when we come to SQL and where we are, one of the reasons of the NoSQL or the start of the NoSQL movement was that replication in MySQL was not good enough, and this was talked about on a blog at Twitter, where one of the main engineers at Twitter wanted to move to Cassandra and wanted to have a reason to move to Cassandra. And he was blogging about how much better Cassandra is on replication than MySQL, and he got a lot of uptake. And from my point of view and looking at how things progress from there, I could say that that one blog was the really big start for the NoSQL movement. But the replication in MySQL and MariaDB has been fixed. Back then, we are as fast as replicate than any of the NoSQL databases. Postgres also includes strong replication. And when it comes to features like non-structured data, we already have had those since 5.3, which is 6 years old. And now we all, both MariaDB and MySQL support JSON, including indexing on JSON. I see also Hadoop and Spark, Pivotal, Hawk, providing data warehousing with SQL. In MariaDB, we added something very recently we call the column store engine, which is now in beta. It should be in production in December, January, where you can get strong parallel processing of data, but still using the same interface. We have added Spider, or we have, which gives you multi-node sharding, and we at some customers, we have been able to replace 100-node Cassandra clusters with only 7 nodes of Spider. So it's a really efficient way, and it can use any of the storage engines that MariaDB provides. And we also adding MyRocks to MariaDB. MyRocks is a version of RocksDB developed by Facebook based on LevelDB, which gives you excellent compression. There were 2 days ago a blog where MySQL user who were using what he called big data had 2 terabytes of data, and when using MyRocks, it only uses 600 gigs of data. And this is with indexing everything. So there's lots of things happening on the SQL sides. And I'm mostly talking about MariaDB and MySQL, just because that's what I'm working on. I'm still doing development in MariaDB. I spend about 50% of my time doing development. So that's the word I'm looking at. But you see similar things happening in other products. I believe that when it's come to big data, and especially combining transactional processing and big data with OLAP, MariaDB is in the front runner. But there's lots of companies here who have their own products. So this is more about comparing NoSQL and other databases with relational databases. There is lots of hype around NoSQL, and these slides, many of these slides is where I'm trying to explain the good and the bad things about NoSQL. I think that NoSQL is fascinating in some sense that we are going back 30 years in database history by removing the relational database from the data. And it has lots of advantages if you want to scale out and you only have a small team who know exactly what they are doing, and you're not going to change the team basically ever. But the big problem is I see there is no standard language. It's very hard to move data because most of the NoSQL versions are good at one specific thing. And if you, when your requirements changes, you basically have to ditch it to something else. And I don't see a solution for that because almost all the NoSQL versions are very different, and nobody's working on a common interface or common view of how things will go, except adding SQL on top. And of course, that will help. but it's also that you have very few connections to different computer languages and applications, which I see as a hurdle. But looking at things that are not technical, the biggest problem I see in today's world when you're looking at big data is that if you're not using a relational database and not something that will be able to survive a long time, and you're looking at some NoSQL solution, be aware that we are living just now in a bubble. The NoSQL camps are getting lots of money, but they have no sustainable business model. I don't believe that many of those companies will exist 5 years from now, and I expect a big consolidation happening within 2 years, just because of the money, because currently you have investors who are looking at MongoDB and saying that, hey, they are making a lot of money, they get lots of investments. I also want to make a lot of money. So people have been throwing around money on the NoSQL camps for the last 5 years in a hope to be able to make another MongoDB in order to make a lot of money. And this was exactly what I saw happening in 1999. And I didn't understand what's happening. And with MySQL, I got the offer for $50 million for the company. And we were only 7 people working on it. It was making good money, but I didn't understand the market. And I didn't want to take the money because I didn't know that will this company actually survive a couple of years. With NoSQL, we are exactly at the same moment. So if you're going to use something with NoSQL, ensure that the company has a sustainable business model, they're actually making money, and they're making enough money to satisfy their investors who wants to have 10 times or 100 times their money back. I don't expect many of the companies will survive many years. So at least be aware of that. So one slide about column store, just to know what's our take in the MariaDB world for big data. So column store is, you have the MySQL front end. So you have the data or performance modules lowest where all the data is stored. You can have any amount of nodes, and all of those are stored in column order, so to make without any indexes. But this makes the processing, the compression very hard and processing very fast. And then you can have many MariaDB servers on top of those, and you can just add many of those so you can spread your load even over data centers, and then you have the clients over. So this gives you basically both on storage, on data processing, and users, you get lots of parallel processing happening. And this is something that should be able to scale to petabytes of data. So the unique thing with MariaDB is that we can have different ways to store things. So this is our solution for all up, in other words, analytical processing. But MariaDB is also very strong in transactional processing. And we are one of the few who can do both extremely well. And if you are looking at where the money is going, so this is a little bit old slide, but it also shows some estimates that are, as far as I know, was roughly correct, where the MySQL camp, which also includes MariaDB, is still will have for the foreseeable future most of the money going. NoSQL is growing, but money-wise, not even close as much. So we will have Matt will have a talk from 451 Research with some newer slides. I think it's later today. So when talking about the big data, if you really want to do that work with big data, there's some things that you need to overcome. Fortunately, storage, which was when I started with databases, were a big problem. It's not that big anymore because machines are notably better. Hard disks, within a few years, they will be the tapes of tomorrow, so you just use that for backups. But what you really need to look at is the access patterns, how you're going to write or read or write or use your data. And if most of the big data solution I see today is really, really write heavy. You just want to write and everything and then access things later. And then Hadoop is one of the better options for that. But if you want to read and analyze things, then there's lots of things that you need to consider. But the biggest problem is probably recovery. If you have a 2 terabyte disk, recovery and copying to somewhere else and re-indexing, that can take weeks with some systems. And that's usually what you can't do. So when big data, you should basically consider that you can't do recovery. You instead have to do high availability. You have to duplicate your data. And also, you also need to keep your caches warm, which is a big thing with failover. Because if you have data that is backed up by hard disks, that's still very common, and even SSDs. If you have a hot system running, and this is something we see a lot at Amazon when they're running MariaDB. And they have some tens of gigabytes of data in memory, and then they have a hot standby. So then, for whatever reason, when the master goes down and you need to move to the slave, all the data of the slave is on disk, and it may take 30 minutes until all the data is read because of the user read in random fashion, random read fashion instead of sequential. And suddenly your website is unattractive for half an hour, which many of your customers may find very unattractive. We have a solution that with max scale where we send the same queries to both the normal one and the standby, and that way keep the data active. But this is something that you need to think about, that standby doesn't really help if you want to have a fast reaction system. And you need to have replication and standby for anything that you work with big data, because recovery doesn't work anymore. Recovery works up to 1 terabyte, or if you can have another server doing the recovery while you have a failover. So then, but the biggest question in a conference like this is, what is big data? When I started with databases in 81, that's where the first code of MySQL was written. And then I started work with an analytical company in Sweden doing market research for some of the biggest companies in Sweden. Back then, this was one of the biggest gas chains petrol chains in Sweden. So they have 1 million users in order as customers. We had 4 million transactions per month, and this is just credit card transactions. So there are about 30 bytes per transactions. So 10 years of data is 1.3 gig. Back then, this was big data. And I did all the work for doing analysis on the Spark station, 5 megahertz, 32 mega memory, and we made all their customers or the gas station happy because we could do real analysis of data. And since then, the CPUs are 700 times faster. We had 1,000 times more memory. The read speed is not that much harder, but the seek speed is 20,000 times faster compared to hard disk back then to SSDs. But the interesting thing is that these transactions, they are about the same size still in Sweden. You don't go and put more gas in your car often. You actually do it more seldom because the cars are more efficient. And so the real data, when it comes to many transactions and stuff, that hasn't really grown. And if you can handle all things in Sweden for all gas stations and probably all stores in Sweden, credit card transactions in a few gig, or in this case, takes time 1,000, 1 terabyte. Still not really big data in the sense that we're talking about. So I would say that most of the big data solutions are hype because it's very few who really have real data as big as Facebook or Twitter. And looking at what you can get today, memory is now at $10 per gig. You can easily get 100 gig of RAM, even on developed machine. It doesn't really cost you anything. Samsung has a 15 terabyte SSD for 10K. Seagate just announced 60 terabyte on SSD. How many here have something that you need more than 60 tera for? Very, very few. And is there anybody from Facebook here? They probably think that's small. But still, big data is not as big as before. And you need to realize that. Of course, this doesn't mean that you shouldn't think about NoSQL and everything else. But you can do most of the things on one machine. And at least you can have one machine as a backup that keeps everything, instead of having your full cluster as a backup. I still think that SQL matters. And not only because it's easier to switch vendor, but the main thing is quickly to adopt to new systems. Because sooner or later, you will happen, if you're working with big data and you're using NoSQL and you don't use a relations system, you will get a boss like I had at Analytica in Sweden. He's really smart, one of the most smartest people I know. But so he usually, when I did this analysis of data, he came to me and said, hey, we need to do this analysis for customer pattern like this. And this was before I had SQL on top of MySQL. So I worked 2 or 3 days, made everything he wanted, went to him and said it's ready. And he said, what's that? I don't need that anymore. No, you need to do it this way. And that happened 2 or 3 times a week. And that's the real word. Your data changes, what you want to have out of the data changes. And that was one of the reasons I wrote SQL on top of my old system, which you basically could call a new SQL system. Because SQL is not perfect, but it allows you to adapt quickly with change. And now, when I had my SQL on top of the old systems, I could just fix a query and give his answer basically half an hour after he asked almost anything. And that was the very, very first version of MySQL. Now we have windowing functions, we have common table expressions. So I could basically do anything he wanted back then, now in minutes. And that's the thing that NoSQL and other systems can't fix. And that's why you need relational databases. Some of the big databases that are running on MySQL are MariaDB, Twitter, Facebook, LinkedIn, Google is using MySQL and MariaDB. Genoscope, which did the first human genome sequencing, storing everything in MySQL. They're using 300 MySQL versions. Booking.com has, I don't know how many thousand nodes of MySQL and also using MariaDB. LSST are planning to store 100 petabytes of data, and they are going to use MyASM, not the transactional database at all, but inside MariaDB. And they are doing that because they are using different computers to generate the data. And the unique thing with MyASM and Area, you can just take the data, move it to another database or another node, and you can instantly use it. So it's very nice for data that's movable, and also we guarantee that the format will not change for the next 100 years. So they can store these on things and access them anytime in the future. Alibaba is using 100,000 instances of AliSQL, their version of MySQL. We are working with Alibaba to merge that into MariaDB. So are you going to use more data? And these guys are all using relational databases. Yeah, 5 minutes. So when to not use a relational database? If you don't know really how you're going to use data, Booking.com is dumping all the user interactions on Hadoop just because we may need it. And that's a good reason. You want to use store user behavior. You want to store pictures, star maps, or DNA, or videos. You store the data in whatever file system, and then you use store the metadata in a relational database. And you also need to think about when using a system. Will that data storage change within the next 100 years? If you're working for government, you may have laws that require data to be accessible. We guarantee that in MariaDB in some of the engines for which we have control. But that may be important for you. So a couple of minutes of questions. Kind of funny to be in a big data conference and say that there is not really big data, but I had expected somebody to protest here, but looking from where I'm coming from, the challenge of these kind of computers with normal data, that was big data then, and the comparison is smaller now. Yes?
Thank you very much. Fantastic talk. I agree with you on big data kind of thing. The question is, what do you think about time series databases for kind of big data, but time series data which are emerging now?
I think that Internet of Things really need time series databases. The nice thing with time series databases is because you store everything in time, so you don't need an index on time. So you can get fantastic writes and still be able to pinpoint data within seconds. So I think those are great. And we don't have a time series database in MariaDB per se, but having MyRox, we get the same benefit because MyRox is basically a sequential write database. It's not as good, but it's closely as good.
Sorry, you mentioned NoSQL. What about graph database?
The graph database is also that the bad thing with NoSQL is that the word NoSQL. It basically should be not at all SQL. Graph database is basically NoSQL database because it doesn't have SQL. But graph databases are good when you want to find who is related to everybody, to something else. With SQL, you can do similar things with common table expressions, but not as good. But it's the same thing with the graph database, like the object-oriented database. It's not a common interface. You always have to do programming to access those. So they will never be as relevant as the relational database that has an easy interface that you can always adapt to. So there are special things, special databases for special things, and very useful for that, but only for just that. This is like when I was in China and I had a talk for 500 persons, and afterwards I didn't get a single question. I didn't really know did they speak English or not. At least they seemed happy.
Hi, you might have been going too fast and I may have missed it, but I was wondering how MariaDB goes about promising the 100-year data access promise.
Okay, so the issue is that I started 81 with MySQL. We had the ISAM back then. It's a very simple storage. And I created this layer of different storage engines just so I don't have to update the data. So with the MyISAM storage engine and the area storage engine, we have a way that we can add new features without compromising compatibility. And we never will remove those from MariaDB. So if we ever need a new storage mechanism for new data, we will create a new storage engine and keep the old one away. So we have some governments who require in Finland 100 data storage. And we guaranteed with that, and because we have given them a promise, that means that we can change the way MyISAM is storage. Time up. Is it that mean that it's time for tea or something like that? Yeah. It's a promise, and we can hold it because of the way we store things. So, thank you.